Okay, welcome to the course on hybrid electric vehicles. See, in today's lecture, we are going to cover the concept and architecture of hybrid electric vehicles. Right? Up till now, we have seen the architecture of electric vehicle as well as IC engine vehicle. And as I have told you that whenever these two technologies, IC engine technology and electrical vehicle technologies are combined together, it will form a new type of vehicle which is known as hybrid electric vehicle. Okay. So talking about the conventional vehicles, they are with internal combustion engine and they provide good performance and long operating range by utilizing the high energy density advantages of the petroleum fuels, right? But these conventional IC engine vehicles bear the disadvantage of poor fuel economy and environmental pollution, right? So the main reason for their poor fuel economies are, the first one is engine fuel efficiency characteristics. They are mismatched with the real operation requirement, right? And second is dissipation of vehicles kinetic energy during braking, especially while operating in urban areas, right? And another reason is low efficiency of hydraulic transmission in automobiles in stop and go driving patterns, right? So these are the disadvantages associated with conventional IC engine vehicle. Now talking about the electric vehicles which are powered by battery, okay, they possess some advantages over conventional IC engine vehicles such as high energy efficiency as well as zero environmental pollutions. But the performance, especially the operation range per battery charge, is far less competitive than IC engine vehicles due to the lower energy content of the batteries, right? So hybrid electrical vehicles which uses two power sources, one is a primary power source and secondary power source. It has the advantage of both IC engine vehicles and electric vehicles, and it will overcome their disadvantages. Okay, so in this particular module, we will study the basic concept and operation principle of hybrid electric vehicle powertrains. Okay, so in the previous sessions, we have covered the basics and dynamic equations of IC engine vehicles as well as electric vehicles, and we have gone through some desired characteristics. Okay, we were talking about the speed torque characteristics or power versus speed characteristics of the traction motor. Okay, so we have seen the characteristics of IC engine vehicle also and traction motor also, and in that we have concluded that whenever we are using the electric vehicle, we will get similar characteristics than the required one. Okay, now we have one more kind of electric vehicle which is known as hybrid electric vehicles into the market. Okay, so we'll see the concept and architecture of these hybrid electric vehicles in this particular module, along with the torque coupling of parallel hybrid electric vehicle, speed coupling of parallel hybrid vehicle, and other drive trains. Okay, so starting with the concept of hybrid electric drivetrains, basically when we talk about hybrid electric drivetrains, any vehicle powertrain is required to develop sufficient power to meet the demands of vehicle performance, right? If I talk about the vehicle, then any vehicle requires, number one is it needs to develop sufficient power to meet demands, and second, it should carry sufficient energy on board. Okay, it should carry sufficient energy on board, right, to support the vehicle driving in the given particular range. Okay. Then talking about the efficiency, efficiency should be very much high, right? And the fourth requirement is it should emit few environmental pollutions. Okay? It should emit few or none environmental pollutants. So these are my basic requirements of any vehicle powertrain, whether we talk about the IC engine vehicle, hybrid electric vehicle, or electric vehicle, right? And we seen that a vehicle may have more than one energy source and energy converter, such as a gasoline, heat engine system, hydrogen fuel cell electric motor system, chemical battery electric motor system, etc. Okay. So the vehicle that has two or more energy sources and energy converter is called a hybrid vehicle. Okay. And a hybrid vehicle with an electric powertrain is called hybrid electric vehicle. Okay, so we will talk about the hybrid electric vehicle. So as the name suggests now, what is there? We should have two powertrain, okay, which are powered by two different energy source. And out of these two energy sources, one energy source must be an electric motor. Then we can call it hybrid electric motor. Okay, so a hybrid vehicle drivetrain usually consists of no more than two powertrains. Okay, more than two powertrain configurations will complicate the system, right? So for the purpose of recapturing the part of the braking energy that is dissipated in form of heat in conventional IC engine vehicles, we have introduced a hybrid drivetrain which has usually a bidirectional energy source and converter. Okay. So the one is either bidirectional or unidirectional. Okay, so now we are available with two drivetrains. You can see one must be bidirectional, one powertrain must be bidirectional, while other can be bidirectional or unidirectional. It depends on the designer. Okay, so let us try to understand this with the help of a small diagram. Sorry. Okay, so here is my first drivetrain. Okay, then it will combine over here, and this is our second drivetrain. And then it is given to the load. Okay, so here is our load. Okay. So now here will be my first energy source. And here is our second energy source. Let me call it number 1 and number 2. And this will be our energy converter. Okay, so energy converter 1 and here energy converter 2. Okay, so let us say this energy converter 2, or you can say this power train 2. This is my power train 2 and this one is powertrain 1. Okay, so this powertrain 2 is, let us say, bidirectional. Okay, and this powertrain 1 is unidirectional. Okay, so what will happen whenever braking has been applied? At that time, whatever kinetic energy is there, that kinetic energy will be fed back to this energy converter, and finally it will go to the energy source. Okay, so this will be our energy source, right? So the one with the strong line is the power flow while we are accelerating, or you can say propelling the vehicle, right? And this dashed line is the flow of power while charging powertrain. Okay, so this is nothing but the conceptual illustration of a hybrid electric drivetrain. Okay, as we can see, we are available with total two drivetrain: powertrain 1, which may be our IC engine, right, and powertrain 2, which may be our electric motor. Okay, so we are using the battery and gasoline fuel as our energy source of energy in this particular case. Okay, so this hybrid drivetrain supplies the required power by an adapted powertrain. You can see. Okay, there are many available patterns of combining the power flow to meet the load requirements. Okay, so what are the possibilities? Number one possibility is powertrain 1 alone delivers the power to the load, right? Possibility 2 is powertrain 2 alone delivers power to the load. Then third possibility is powertrain 1 and 2 deliver power to the load at the same time. Okay, then fourth possibility is powertrain 2, you can see it is bidirectional. Okay, here this is my powertrain 2 is bidirectional and powertrain 1 is unidirectional. Okay, so in this particular case, powertrain 2 will obtain the power from the load. In which case? In the case of braking. Okay, we call it regenerative braking. What do you mean by regenerative braking? While applied braking, what will happen? The kinetic energy which is produced during braking, that kinetic energy is utilized to charge the battery. Okay, so we will be able to charge the battery on board, right? Then the fifth possibility is powertrain 2 obtains the power from powertrain 1. This is also possible. Okay, as we have the energy source of gasoline in this particular case, and if I want to charge the battery, then this is also possible that this energy converter 2 will draw some power from the energy converter 1, right? Then another possibility is powertrain 2 obtains the power from powertrain 1 and load at the same time. Okay, while braking, load is also delivering the power, and this powertrain 1 is also delivering the power to powertrain 2. Another possibility is powertrain 1 delivers the power to powertrain 2, and powertrain 2 will deliver the power to the load. This is also true. Okay, you can also work your this particular way. Another is powertrain 1 will deliver the power to the load, and load will deliver the power to the powertrain 2. Okay, so total 8 or 9 numbers of possibilities are there. Okay, so in each and every possibility, our hybrid electric vehicle will work. Okay, so in the case of this hybridization with a IC engine, you can say, okay, in our case it is powertrain 1, and a battery electric machine, in our case it is powertrain 2. Okay, so if I talk about the first pattern, we have seen the engine alone is in propelling mode, okay, and this may be used when the batteries are almost completely depleted and the engine has no remaining power to charge the batteries, or when the batteries have been fully charged and the engine is able to supply sufficient power to meet the power demands of the vehicle. Okay. Talking about the second pattern, it is the pure electric propelling mode in which the engine is shut off. This pattern may be used in situations where the engine cannot operate effectively, such as at very low speed or in areas where emissions are strictly prohibited. Okay. Then talk about the third pattern. What was third pattern? Both the powertrain 1 and 2 will deliver the power to the load at the same time. Okay. So this pattern is the hybrid traction mode and it may be used when a large amount of power is needed, such as during if we have some sharp acceleration or steep hill climbing. Okay, in that case, we may take the power from both the powertrains, right? And then fourth pattern was the powertrain 2 will obtain the power from the load, which was the case of regenerative braking. Okay, so in the regenerative braking mode, by which the kinetic or potential energy of the vehicle is recovered through the electric motor functioning as a generator. Okay, so the recovered energy is stored in the batteries and it is going to be used later on, right? This was the pattern number 4. Now talking about the fifth pattern, where we have considered that powertrain 2 will obtain the power from powertrain 1. What does it mean? It means that the mode in which the engine charges the batteries while the vehicle is at standstill, okay, or coasting or descending a slight grade in which no power goes into or comes from the load. Okay, if you are going downwards to the hill or our vehicle is at standstill, at that time what should do? Whatever energy is there from powertrain 1, that can be utilized to charge the batteries of powertrain 2. Okay, so in this way this will work. Whatever possibilities we have considered, each and every possibility will work with the hybrid electric vehicle. Okay, so the varied operation modes in a hybrid electric vehicle create more flexibility over a single powertrain vehicle. Okay, so with proper configuration and control, applying the specific mode for each special operating conditions can optimize the overall performance, efficiency, as well as emissions. Okay, but as we know, in a practical design, deciding which mode should be implemented depends on many factors. What are that factors? The factor is the physical configuration of the drivetrain, the powertrain efficiency characteristics of the load, etc. Okay, so operating this each powertrain in its optimal efficiency region is the essential for the overall efficiency of the vehicle. Okay, say if I talk about the IC engine, the IC engine generally has the best efficiency operating region with a wide throttling opening. Okay, but operating away from this region will cause the efficiency to suffer a lot. Okay, on the other hand, efficiency suffering in an electric motor is not as detrimental when compared to an IC engine that operates away from its optimal region. Okay, so the load power of a vehicle varies randomly in real operation due to frequent acceleration, deceleration, and climbing up and down grades, right? So let us try to see this particular case. A load power which is decomposed into steady and dynamic components. Let us try to understand this with the help of some graph. Okay, I am going to draw a normal graph of time versus load power, time versus average power, and time versus dynamic power. Okay, so this will be our reference line. Okay. Now talking about the load power requirement may be different like this. Okay, depending on our road conditions or traffic conditions, we may have this kind of load power, right? So this is our load power and it is plotted against time. Similarly, if I talk about the average power, definitely average power will be constant throughout the time. Okay, we are finding out the constant value, and dynamic power may again have some fluctuations like this. Okay, so this is our dynamic power versus time, and this is my average power. Right, so this is what we are having. Right, now here you can see that the load power of a vehicle varies randomly, okay, in the real operation due to frequent acceleration, deceleration, sometimes climbing up and climbing down the grades, as you can see in this particular figure. Okay, so actually the load power is composed of the two components. One is the steady power, which is this average power, which has a constant value, and another one is the dynamic power. Okay, so we can say our load power is nothing but the combination of this average power plus dynamic power, which will have a zero average. Okay, so in hybrid vehicle strategy, one powertrain that favors steady state operation, such as an IC engine fuel cell, can be used to supply the average power, and on the other hand, other powertrains such as an electric motor can be used to supply the dynamic power. Okay, so the total energy output from the dynamic powertrain will be zero in a whole driving cycle. What does it mean? It means that the energy source of the dynamic powertrain does not lose energy capacity at the end of the driving cycle. It functions only as a power damper. Okay? In a hybrid vehicle, steady power may be provided by an IC engine, a Stirling engine, a fuel cell, etc. The IC engine or the fuel cell can be much smaller than that in a single powertrain design, because the dynamic power is taken by the dynamic power source and can then operate steadily in its most efficient region. Okay? So the dynamic power may be provided by an electric motor which is powered by electrochemical batteries or ultra capacitors, flywheels, or their combinations. Okay, so this is how the requirement of load power will be fulfilled by this particular hybrid electric vehicle. Okay, so now the idea is clear. We are available with two energy sources. One energy source may be anything, but the another energy source must be electric. Okay, so it may be electric battery, it may be fuel cells, it may be ultra capacitors, etc., etc., right? And whenever we talk about the two components of this load power, one is the average power, another one is the dynamic power. So average power will be delivered by the IC engine and dynamic power will be delivered by the chemical batteries, and this is how the fulfillment of load power will be done. Okay, so this is how our actual hybrid electric vehicle is going to work. You can see a very simple powertrains are there. First powertrain consisting of IC engine and energy converter, second powertrain consisting of battery and electric motor. Okay, and we have seen the numerous alternatives to operate this particular device. Okay, depending on our requirement, on road requirement. Right, now let us see some of the architectures of this hybrid electric drivetrains. Okay. So the architecture of the hybrid vehicle is loosely defined as the connection between the components that define the energy flow routes and the control ports. Okay. Whenever you talk about the architecture, what do you mean by architecture? Okay, architecture of hybrid electric vehicles. Okay, so it is nothing but the connection between the components that define the energy flow routes and control port. Okay, so traditionally these hybrid electric vehicles were classified into two basic types. One is known as series hybrid electric vehicle and another one is parallel hybrid electric vehicle. So we have these two types, series hybrid electric vehicle and parallel hybrid electric vehicle. Okay, so it is interesting to note that say in year 2000 some newly introduced hybrid electric vehicles could not be classified into these two kinds. Okay, though we are available with the series HEVs and parallel HEVs, but whenever the newly hybrid electric vehicles were introduced in 2000, they could not fall under these two categories. Therefore, there is more categories nowadays defined. So hybrid electric vehicles are now classified into four categories. Okay? And these are known as series hybrid, parallel hybrid, then series parallel hybrid, series parallel hybrid, and the fourth one is complex hybrid. Complex hybrid. Okay. Now let us try to understand this. For what do you mean by series hybrid electric vehicle? What do you mean by parallel hybrid electric vehicle? Now, as the name suggests, you will understand for surely that whenever I talk about the series hybrid, that means two powertrains are to be connected in series. Whenever we talk about the parallel hybrid, at that time, two powertrains are to be connected in parallel, like we have seen this. Okay, this is the case of parallel hybrid electric vehicle. Okay, so let us see these classifications, right? So the first we'll start with the series hybrid. Okay, so here I will have fuel tank. Okay, and that fuel tank is connected to internal combustion engine, which is my IC engine, right? And then there is another source. Okay, this source is battery. Obviously, we are talking about hybrid electric vehicle. Okay, so one powertrain must consist of electric motor. Okay, so to control this electric motor, we will require one power converter over here, and this power converter is now connected to the electric machine or motor. Okay. and this electric motor is connected to the transmission. Okay, it may be a single gear transmission or a multi-gear transmission, right? Now, in between this IC engine and power converter, we will be having one generator. Okay, so this is my typical block diagram, okay, of series hybrid electric vehicle. So this is fuel tank, right? This is my engine. Here we will get some generator. This is energy source, that is battery. Then I will have power converter over here, and finally electric motor. Okay, and this is our transmission. Okay, so this is first case, series hybrid. Now if I talk about the parallel hybrid, then obviously you can see that both the powertrains will be parallel to each other. Okay, so on the one powertrain I will be having one fuel tank, then there will be IC engine. Okay, and parallel to this we will have another powertrain too, which is consisting of electric motor. Okay, so I will have three blocks. One is battery, another one is power converter, and third one is my electric motor. Okay, and these two powertrains are parallelly connected to the transmission system like this. Okay, so this one is my fuel tank, IC engine. This is electric motor, power converter, and energy source battery. Okay, and here is my transmission system. Okay, so you can see in this particular case two powertrains are there, but both the powertrains are connected parallelly to each other, and that is why this combination is known as parallel hybrid. Now the third one is series parallel hybrid. Okay, so it is nothing but the combination of these two particular cases. Okay, so you can see series combination and parallel combinations of hybrid vehicle in this particular configuration, right? So again we will have fuel tank over here. Okay, this may be my IC engine, right? And then we have battery, power converter, then electrical motor is over here. Okay, so these are my separate powertrains. Okay, I am talking about the powertrain 1 over here, right? And this is my powertrain 2. Okay, now here our transmission system will be there. Okay, and there's this particular configuration is series parallel hybrid. Okay, so parallelly also they will be connected like this. Okay, this is my parallel hybrid electric vehicle, and if I talk about series hybrid electric vehicle, then we will require one generator over here, and this is series combination. This is my transmission system, right? So series hybrid vehicle and parallel hybrid vehicle both are combined together, and that will create one series parallel hybrid electric vehicle. Okay. So this is our third particular configuration, third architecture of hybrid electric drivetrains, and the fourth architecture is known as complex hybrid. Okay. Now let us see what do you mean by this complex hybrid. Okay, so we will have again same, one is IC engine and another one is electric motor, but this time we will use not only one electric motor but number of electric motors will be used. Okay, so let us see this is our fuel tank, then my IC engine would be over here. Okay. This consists of one powertrain, right? Then I have another powertrain. This is battery. Then there is power converter. Then electric motor. Okay. So this is another powertrain. Okay. Powertrain 1 and powertrain 2. Then electric motor will make one more powertrain. We will call it powertrain 2. Okay. And as I have told you, whenever we talk about the complex hybrid vehicle, at that time we are going to use more than one electric motor. Okay, so this is parallel hybrid electric vehicle which we have connected like this way. Okay, this is our transmission. Now what I am doing, I am connecting one more electric motor over here. Okay. And this electric motor is mechanically coupled with IC engine. Okay, and electrically coupled with power converter. Remember, in all these block diagrams, whenever I talk about these two lines, okay, I am talking about this. These two lines indicates mechanical coupling and single line indicates electrical link. Okay. And there is one more motor which I am connecting over here. Okay. And these motors are connected in series to each other like this, supplied by a source of battery. Okay, so this is our fourth possibility of hybrid electric drivetrains, that is complex hybrid electric vehicle. Okay, now let us try to understand all these possibilities one by one, right? So talking about the series hybrid electric drivetrains. Okay, so a series hybrid drivetrain is a drivetrain, you can see over here, is a drivetrain where two power sources feed a single power plant. This is electric motor. Okay, and it will propel the vehicle. Okay, so the most commonly found series hybrid drivetrain is the series hybrid electric drivetrain, which is shown in the block diagram. Let me try to draw block diagram for this. Okay, we will talk about the general block diagram only. Let me draw this. Okay, the first one is engine. Okay, now this engine needs to be connected to some transmission system. Okay, so at the one end we will use this transmission system. Okay, this is my mechanical transmission. Right? So we do have some wheels connected to this transmission, right? Like this. Okay. And what are our desired characteristics? I should have this kind of shape. Okay, so this is my tractive effort versus vehicle speed. Okay, so this is our desired speed torque characteristics. Tractive effort versus speed, and speed torque characteristics will be achieved by the motor. Okay, so in between we will have some traction motor which is connected to this mechanical transmission, right? So let us have that traction motor over here. Okay, so this traction motor is mechanically connected to transmission, right? And to control, when we talk about the electric vehicles other than the two-wheelers, then definitely this traction motor will be consisting of three-phase motors. Okay, it may be three-phase induction motor, right? So to control the speed of this motor, what we require some converter, okay, which is known as motor controller, right? So we will have one motor controller over here. So this is my power electronic controller. Okay, motor controller. Okay. Now this engine will be connected to some generator. Okay. So here we will have one block which is generator, and then we should have another block which will control the flow of power, right? So it may be a rectifier also. In case of a induction motor, whatever energy is there, this energy will be AC, DC, right? So to convert this energy into AC, we may require some inverter also, or if it is AC, then we will require some rectifier also. Okay, so suppose this generator produces AC supply and my motor is DC, then in that case we should require rectifier in this particular case, right? So this is one powertrain which we have developed. Okay, let us try to connect this powertrain. It is connected in this particular fashion. Okay, and this engine is being supplied with the gasoline. Okay, so we may have our fuel tank over here. Okay, this is my fuel tank. Okay, it is connected to over here. Right now we may have another powertrain. Okay, and we know both are connected in series. So if we go back to the block diagram, you can see this IC engine and power converters are connected to a generator, right? So generator we already have, IC engine is already have. So to generate this, to this generator, now we should connect one another powertrain which is with the help of a battery, right? So we may have this battery over here. Oh, sorry. Coming back to the block diagram, yes, right? And then we should have one battery. Okay. So let us say this block, there are number of cells connected in series like this. Okay, so this is our battery. And to charge this battery, we will require a battery charger, right? So this will be my battery charger. Okay. And then again, I will require DC to AC converter or AC to DC converter. So one power electronic converter would be there, okay, which will convert any power, whether it is DC to DC or AC to DC, which is connected to this motor controller. Okay, so this is our series hybrid electric vehicle. Okay, so there is one possibility of power flow is from power engine 1, right? And another one is this engine will help us to charge the battery. Okay, then there is another possibility that this battery will provide the power to the load, or in case of braking, this load and kinetic energy will help to charge the battery, or to charge the battery we will use this charger. Okay, so this is how the flow of power will take place in this particular vehicle. Okay, so remember always this motor needs to provide this kind of torque speed characteristics. Sorry. Okay. This is the desired torque speed characteristics of the motor, torque versus speed. Okay. So you can see the unidirectional energy source is nothing but a fuel tank. Okay, and the unidirectional energy converter is an engine which is coupled to an electrical generator over here. Okay, so the output of this electric generator is connected to an electric power bus through this electronic converter. Okay, it is rectifier in this particular case, and the bidirectional energy source, which is nothing but an electrochemical battery pack, it is connected to the bus by means of a power electronic converter. In this case, it is DC to DC converter. Okay, so the electric power bus is also connected to the controller of the electric traction motor. Okay, the traction motor can be controlled either as a motor or a generator, and in forward or reverse direction. Okay, so this drivetrain may need a battery charger to charge the batteries by a wall plug-in from the power network. Okay, so these series hybrid electric drivetrains potentially have different operating modes. Okay, so we should see these operating modes, or we already have seen the operating modes of this particular thing. Similarly, if I talk about the parallel hybrid electric drivetrain, okay, then what will happen? See, if I talk about this battery, now this battery needs to be connected to motor controller directly, right? And this engine needs directly connected to the mechanical transmission. Okay, so powertrain 1 will be connected parallel to the drivetrain 2. Okay, so we are not going to draw the block diagram of this particular thing. Okay, but talk about some hybrid electric drivetrains. Now this hybrid electric drivetrains offers you some disadvantages. Okay, disadvantages of HEVs, series hybrid electric vehicles is, first is the energy from the engine is converted twice. First mechanical to electrical in the generator, and then electrical to mechanical in the traction motor. Okay, so what will happen? The inefficiencies of the generator and the traction motor will add up, and losses may be significant. Okay, so in this case you can see losses may be significant. The first disadvantage of series hybrid electric vehicle. Second, we talk about the generator. We are using the generator. Okay, and whenever you add the generator along with the traction motor, then what it adds up? It adds up additional weight as well as cost. Okay, so generator adds additional weight and cost. Okay, and the third is talking about the traction motor. Then traction motor must be sized to meet the maximum requirements, since it is the only power plant which is propelling the vehicle. Okay, so the size of traction motor is high, is very big. Requirement is very much, because this is the only possibility. You can see there is only traction motor which is connected to mechanical transmission, right? So to propel the vehicle, we must depend on this traction motor only. Okay, so whatever these torque speed requirements are there, this torque speed requirement must be satisfied with this traction motor only. Okay, so we should select more size or more power rating of this traction motor. So these are the some disadvantages which are associated with series hybrid electric vehicle. Now we know parallel hybrid electric vehicle. Okay, it is a drivetrain in which the engine supplies its power mechanically to the wheels, like in a conventional IC engine powered vehicle. Okay, it is assisted by an electric motor that is mechanically coupled to the transmission. Okay, so what happens in this case? The powers of the engine and electric motor are coupled together by mechanical coupling. Okay, so the mechanical combination of the engine and electric motor power leaves the room for several different configurations. Okay, so we have seen the configurations of these particular cases. Okay, and that is why this is somewhat advantageous. This parallel hybrid electric vehicle is somewhat advantageous to the series hybrid electric vehicle, right? So we shall stop here. We have seen the architecture and basic idea of hybrid electric vehicles. Now in the next lecture, we will see some torque equations in these particular cases, and we'll see more possibilities of series hybrid electric vehicle as well as parallel hybrid electric vehicles. Okay. So if you have any questions, then you may ask. Okay. This is nothing but the introduction to the hybrid electric vehicles. Once we are done with the introduction to hybrid electric vehicles, then we will move on to the propulsion unit, which is our main, as an electrical engineer, it is our main target. How we are going to propel the entire vehicle. What are the different what are the different alternatives available to us? Either we may use induction motor, we may use switch reluctance motor, we may use permanent magnet motor. So which motor is suitable for which kind of load, and depending on that load, we will try to design a motor or propulsion unit for such electric vehicle. Okay. So if you have any questions, then you may ask.